Next is file types. An operating system must recognize and support files of different types. If an operating system recognizes the type of a file, then it can operate on that file. Various operations on the file include reading, writing, appending, etc. A common technique for implementing these file types is to include the file type as a part of file name. Usually the name is split into two parts, name and an extension, usually separated by a period or dot. For example, resume.docx, server.c, reader.cpp, etc. Here resume is the file name, docx is the extension. The system uses this extension to indicate the type of the file and the type of the operations that can be performed on the file. .com, .exe files are binary executable files. These files can be executed. .sh is a shell script file in ASCII format. This contains some commands to the operating system. And application programs also use extensions to indicate the file type. Java compiler usually expects source file to have .java extension. Microsoft Word processor expects all its file to end with a .doc or .docx extension. Here is a table which indicates different file types, their extension and function. First file type is executable files, usually come with the extension .exe, .com, .bin or none. These are ready to run machine language programs. Then second category is object files, extension .obj or .o. These are compiled machine language programs, but they are not linked programs. Then source code. Source code files usually come with extension C, cc, .java, .pas, .asm, .a, etc. This represents source codes in various languages. Then batch files, extension .bat or .sh. These are some commands to the command interpreter. Then textual files come with extension .txt or .doc. These are textual data or documents. Then word processor. Extensions include .wp, .tex, .rtf, .doc. These are various word processor formats. Next category, library files. Extensions .lib, .a, .so, .dll. Libraries of routines for programmers. Then print or view .ps, .pdf, .jpg, ASCII or binary file in a format for printing or viewing. Then archive files .arc, .zip, .tar. These files are grouped into one file, sometimes compressed for archiving or storage. Then last category, multimedia files come with extension .mpeg, .mov, .rm, .mp3, .avi, binary files containing audio or audio-video information. Next is file structure. File types can be used to indicate the internal structure of the file. Certain files must conform to a required structure that is understood by the operating system. Operating system requires that an executable file have a specific structure so that it can determine where in memory to load the file and to execute it. There is one disadvantage of the operating system which support multiple file structures. the resulting size of the operating system becomes very large. For example, if the operating system defines 5 different file structures, it needs to contain the code to support all these file structures. Thus, the size of the operating system becomes large. And coming on to the structure of hard disk, the disk systems have a well-defined structure. You might have already studied disk surface or platters are divided into tracks. Tracks are further subdivided into sectors, etc. So here all disk input output operations is performed in a unit of one block, and all the blocks are of same size, and the size of the block is determined by the size of the sector. Hence all the disk system will have a well-defined block size determined by the size of the sector. Usually, the physical record size will not exactly match the length of the desired logical record. That means there will be a difference between the size of physical record and logical record. So, packing a number of logical records into physical blocks is a common solution to this problem. For example, Unix operating system defines all files to be simply as a stream of bytes. Each byte is individually addressable by its offset from the beginning. And here the logical record size is 1 byte, and the file system automatically packs and unpacks bytes into physical disk blocks, 512 bytes per block. The logical record size, physical block size, and the packing technique determines how many logical records are there in a physical block. So we are packing up logical records into physical blocks. And this packing can be done either by the user's or application program or by the operating system. Because the disk space is always allocated in blocks only, the some portion of the last block of each file is usually wasted. This problem is known as internal fragmentation. Next is different access methods. Files are usually used to store the information. Information in the file can be accessed in several ways. Two main access methods are sequential access and direct access. First one is sequential access. The information in the file is processed in order, one record after other. Editors and compilers usually use this technique. And there are two functions used for implementing this sequential access. First operation is read next, and second one is write next operation. This read next operation reads the next portion of the file and automatically advances the file pointer. Similarly, write next operation appends to the end of the file and advances to the end of newly written material. In addition to this, there is another operation which is known as reset operation. Such a file can be reset to the beginning, and on some systems a program may be able to skip forward and backward n records for some integer n. So these are the operations that are supported on sequential access method: read next, write next, and reset. And second method is direct access method. In direct access method, We will consider the file as it is made up of fixed length logical records that allows the programmers to read and write records rapidly in no particular order. For direct access file, it is viewed as a numbered sequence of blocks or records. Thus, we can read any block without any order. Direct access files are of great use for immediate access to large amount of information. Database systems are often of this type. When a query comes, we compute which block contains the answer and then that block can be read directly. For direct access, the operations must be modified to indicate block number as a parameter. So instead of read next operation, here we are using read of n. Read of n, here n is the block number. And instead of write next, here we will use write of n. And this read of n is used for reading nth block randomly, and write of n is used to write into the nth block. Then in addition to reading and writing, there is another operation which is position file of n, where n is the block number. We can reposition the file pointer to the desired block. So these are all the operations supported in direct access. Next is other access methods, and these methods can be built on the top of base methods like sequential access and direct access. Usually these methods involve the construction of an index for the file. The index contains pointers to various blocks. In order to find a record in the file, we need to first search the index and then use the pointer to access the file directly and to find the desired record. For large files, index file itself may become too large to be kept in memory. One solution to this problem is to create an index for the index of the file. That means we need to create a primary index and a secondary index. The primary index contains pointers to the secondary index files, and secondary index file contains or which will point to the actual data items. So in effect, this will create a two-level indexing. In case of IBM's indexed sequential access method, ISAM, it uses a small master index that point to the disk blocks of a secondary index, and the secondary index blocks point to the actual file blocks. In order to find a particular item, we first make a binary search on master index, which provides the block number of the secondary index. This block is read in, and again a binary search is used to find out the block containing the desired record. Finally, this block is searched sequentially.